Hello everyone. Today I'll try to explain you back propagation with example. Okay, let's see here. Back propagation, it's only used for training, and for the inference you need back propagation. Back propagation, it means I will try to update the laws, the weights of the network. So in that case I will have less error. So assume that we have this simple network. I have two inputs, x1, x2. Yeah, this should be x2, and they have one hidden layer with two neurons and two outputs. So if you see here h1, it's if I would like to have the output of h1, it somehow has the dependencies to x1 weight 1 and x2 weight, let's say 3. And now each node in the hidden layers and output layers, just imagine it has two parts. The first one is h1, if we see h1 here, and this is the sigmoid function. And for example, to calculate the h1, it's for this formula: x1 multiplied by weight 1 plus x2 multiplied by weight 3 plus bias, and this is x1 weight 1 and x2 weight 3 plus the bias. Now this is the first part of the neuron, and the second part is sigmoid. Please focus on this because this will be used in the partial derivative and chain rule. And the sigmoid, let's see, I'm using the sigmoid, and to have this hi, let's assume we have hi here, and the sigmoid function, the second part of the circle of the node, it will be the sigmoid, and it's only for hidden layers and output layers. So now let's go to the next slide. Let's assume I'm just give some random values here just to make it very simple and very clear for everyone. So I have input and weights. So I have value. I just generate values for all of these inputs, and they have a target values. So for instance, y1 and y2. The network in the inference time, the network has, if I have x1 and x2, and the network in that inference time or testing time has to get values close to this or exactly this. So now let's go dive into this, how to is this working. So as you can see, as I said in the beginning, we have to calculate the h1, and h1 is calculated by this x1 multiplied by weight 1 blah blah blah, and this is the first part of the neuron h1. As I said here, it's considered as two parts, and the next one is to use a sigmoid function. So now h1 output, this I have two outputs, one and this, and h1 output, this one here, it will be used as an input to the next, let's say, layer, and for the h2, it should be the same, and I here have the output of the h2, and these two values, this h1 and h2, will be used as an input to find the y1. This we will see it here. So yeah, from the previous slide, I have the output of h1, sigmoid of h1 and sigmoid of h2, and I get these values. Now let's try to find y1. So to find y1, it's easy. This is the it will be considered as an input, not h1, but sigmoid function of the h1. As I said, we have to split. It's considered as two parts. So this will be sigmoid of h1 multiplied by weight 5 plus the sigmoid of h2 multiplied by weight 7 plus the bias b2, and this is the simple calculation. Hopefully this is right, because if you find some error, it just you can see the formula here, I mean, maybe there's some mistake or maybe these values are wrong, but I try to make it precisely. So now we have found y1 and y2. As I said, next we have to do y1, I mean sigmoid of y1 and sigmoid of y2. The sigmoid you can use any sigmoid function, but just stick with this one as just to make it simple. And now I would like to calculate the loss function. Let's see, I have this value here of y1 and y2, right? And now I will try to compare it with these values here. And if they are close, it means my system is working perfectly. If they are not close, it means I have to retrain the model. It means update these weights and bias. Only weights and bias. Input you don't need to, it's just input. Input will be fixed for any number of iteration. Right. And for calculating the loss, I use this simple equation. So it's the summation of 2 half of the target minus output square. This 2, it means how many number of classes. So for instance, I have two classes here. So the loss T1 minus output 1, T2 minus output Y2. And this is the loss. It's easy to calculate. So let's say this is the loss function of my network. And I will see, let's see, this is just like it should be close to 0. So how to do this? So to do this, we have to update these weights. Update these weights to minimize the error. And as I said, this is the error of the current configuration, current weights. Now the idea is to make it null 0.000 something. This is the goal of any network. And now here, this is the backpropagation chain rule and partial derivative. Now to update this weight 5, what's the formula? It's derivative of loss in terms of y5. But as you can see here, there is no connection between loss and weight 5. You can see here weight, this is y1, but weight loss function, it was calculated, it's outside, so there is no direct connection to this. So what we should use, it should use a chain rule. So to calculate the weight, to update the weight 5, we have to calculate derivative of loss in terms of y1. So here's the loss. Let's see, calculate the loss, and it depends on this value, right? And next, see, derivative of loss in terms of y1, sigmoid of y1, then multiplied this output, it depends on this, so I have to add it here, the derivative of sigmoid y1 in terms of y1. Then y1, it depends on y5, right? So it means derivative of y1 in terms of y5. And let's start with the first one here, loss, derivative of loss in terms of y1. So here's the formula, right? And where is the y1? Y1, it's only in this term, in the first term here, before the plus. So to have the derivative, it's easy for this term here. The second term after the plus, there is no t1 here because the derivative will be only in term respect to y1. It will be deleted. Okay. Now for the derivative, it will be just take this 2 outside here like this, multiplied by 0.5. This is the equation, and you will see t1 minus the sigmoid of y1 to the power of 1 multiplied by the derivative of the sigmoid y1 would be -1. Okay, So now this two will go with this one, and I have only t1 minus output 1 divided by multiplied by minus, and this I have this t1, it's here, and y1 I have it here, which is calculated, it's already calculated in the, let me just go back, it was calculated here. So now we have found the derivative of loss with respect to sigmoid y1. Yeah, and as I said here, this one will be 0. So you don't care about this. Now the next, let's calculate this, the second term, this one here. To calculate this term, if you see y1, I mean the sigmoid of y1, it was I used this sigmoid function, right? And the derivative of this sigmoid function, it's this one here, the sigmoid y multiplied by 1 minus this. You can easily find it in, just Google it, find the sigmoid derivative, and just replace this sigmoid y1, it's already defined in the previous slides. This you will get this value here. Then next I need to calculate this the derivative of y1 in respect with w5. This is the formula. If you remember in the beginning, this is y1. Let me just go back. Oh, it's, yeah, this one here. So now I would like to get the derivative of y1 in respect with y5, w5. So the wy5, it will be 1, and I will just take this one, this value, and the second part will be 0. So let's be back to the u. So the output of this, of the derivative, will be the output of h1, or sigmoid of h1, multiplied by 1 plus this one will be 0, 0, 0, and the output will be 0.55. Now to calculate, then go back. So we have here the error at w5. So we found all of these terms. Now just multiply these values, and now to calculate the weight, the new weight. So the old weight was weight 5. So for instance, it was 0.15. So the next weight, the updated weight, will be the weight 5 minus any learning rate multiplied by this value. Sorry, I guess it should be 0.0077. So my mistake, sorry. And let's assume this, the learning rate is 0.5. So now the new value, or the new weight 5 will be this. Okay. And now we will try now to find, this is only the calculation, this only calculation only for w5. We will do it for the w6 with the same concept. We will do it for the w7, weight 8, and we will calculate also for the b2, bias 2, and again we will do it also for respect with w1 and w2 until we get all of these weights. So if you see here, as I said in the beginning, x1 and x2 are constant as an input. It has to be fixed. No change in these two values. For example, if you have only 2 nodes. Now I have only, this example just only showed one value, weight 5. To find you have to do it the same steps for respect for the all weights and bias, and try again to train the model, train the network, go to this direction and find the loss. And if the loss is greater than a specific, I don't know, threshold, you can also update the weight again and do it again. And after several iteration or epochs, it has to be stop, or this is the main concept of any deep learning algorithm. I think I finish here, and if you have any question, just drop it in the comment, and I will try to find the time to reply on your questions. Thank you, and see you later.